Hey everybody! Alright, moving on to areas of circles. I'm sure you've all heard the formula. Area of a circle is pi times the radius squared. So the question is why? That is not at all obvious. So let's figure out where that comes from. Here's a pizza. Cut into fourths, half pepperoni, half cheese. Here's that same pizza with the 4 slices rearranged. 2 pepperoni slices pointing up, 2 pepperoni slices pointing down. Same area though, the area of this shape is the same area of this. It's the same 4 pieces. Same area, same amount of pizza. Here's another pizza cut into 8ths. Half pepperoni, half cheese. Here are the same 8 slices rearranged. Half of the pepperoni, those half point up, and then the other half cheese are pointing down. Same area, same amount of pizza, just different arrangement. So the area of this is equal to the area of this. You might start to notice this is starting to look like a shape that we know how to handle. That's kind of looking parallelogram-ish. Not a parallelogram, but pretty close. I wonder what would happen if we cut a pizza into 16 slices. Or 32 slices. This is what would happen. Yes, I had one of my students do this a few years ago. That is a large pizza cut into 32 slices. Then I had them rearrange it so half point up, half point down. There they are, 32 slices. That looks even more, not only parallelogram-ish, I mean that really looks flat there and flat there, that looks actually rectangular-ish. I wonder what 64 slices looks like. That's what 64 slices looks like. I had one of my students do that last year. And if we rearrange that, look at that. Really rectangular-ish. So we're on to something. So let's come back to this. If we think of that last picture I just showed you of the 64 slices, we can see that if we could cut slices infinitely thin, that eventually forms a rectangle. So if we take this idea to the logical limit, that's a calculus term, then this figure approaches a rectangle. But for ease of drawing, I just drew the 8-slice pizza. Here are the 8 slices. Same area, same amount of pizza. So if I can get the area of this, that's going to be the area of this. And thinking back to that last picture, which was essentially a rectangle, we would just have to multiply the height of the rectangle by the base of the rectangle. So let's see, what's the height of the rectangle? Height of the rectangle is this edge of this slice of pizza. Back on the original picture here, what is that edge of that cheese slice of pizza? That's a radius. So that's the radius. These 4 crusts of the pepperoni, if we look at the original picture, those 4 crusts represent half of the length around the circle, half of the circumference. Half circumference. So I'm going to bring back this laptop. Same idea here. This edge of that little sliver of pizza was a radius of the original circle. And because half the crust are here and half the crust are here, this is half of the circumference. Half of the circumference. Same thing's going on the paper. So let's do it. The area of this, which is equal to the area of this, is, if we think of it as a rectangle, which is what it approaches, it's base times height. Base is 1/2 circumference times the height, which is really just a radius. And we know from previous videos, the formula for circumference is 2 pi r. So if you see what I did there, I just replaced the c with what we know it is, 2 pi r. And hopefully you can see where this is going now. Half times 2 is 1. 1 times pi is pi. Pi times r is pi r squared. There it is. Answer is yes, really is pi r squared. So let's use it. If I tell you the radius of the circle is 4 inches, and I ask you for the area of that circle, what's the answer going to be? And if you're reaching for your calculator, you're making a mistake because it didn't say to round off. So the answer would be pi times the radius squared. 4 squared is 16, so 16 pi inches squared. There it is. If it said to round off, we would of course go to our calculator. So, your book, down the bottom part of the page here, is going to be asking you to find areas of shaded regions. And these are actually nice problems because they're combining multiple shapes in one problem. So to get the area of the shaded region here, you would have to get the area of the rectangle, which has its own formula, and then subtract the area of the circle, which has its own formula. Here you would do the circle minus the triangle. So you have to treat each shape individually and get their areas and subtract the circle minus the triangle. This one's different. This one is the triangle minus the unshaded circle. Triangle minus circle. So I drew a few things out here to make a couple of points, and then I'll do one problem with you, and that'll be it. So again, this is circle minus triangle. This is triangle minus the circle. If you struggle with these, I would advise you to draw the shapes separately. Just draw the circle, and separately just draw the equilateral triangle. Equilateral triangles, we have a bunch of formulas we could use. We could do 1/2 AP because it's a regular polygon. We could do half base height. We could do the 2, 3, 4 formula, side squared root 3 over 4. We could do Heron's formula. So depending on what information it is you know about that triangle should determine which formula you use to make it easiest. But what I want you to notice is, if I was going to do the half AP formula for this triangle, there's my apothem, there's the radius of the triangle. Notice that the radius of the triangle is also the radius of the circle. On the other hand, over here, the radius of the triangle is not the radius of the circle. It goes beyond the circle. The radius of the circle would be this. So the apothem of this triangle is also the radius of that circle. So you need to pay attention to what these lengths represent for each individual shape. All right, so let's do one problem as an example. You can also look at your book for more examples. So the problem is, this is an equilateral triangle inscribed in a circle, radius of 7 centimeters. And the question is, to the nearest tenths, what is the area of the shaded region? So I'm going to give you a moment to work on that. You can hit the pause button. All right, so I'm going to start going through this with you. And here's how I'd like you to show your work when you submit your homework problems. I want the first line to be what the shapes are. Are you doing triangle minus circle? Are you doing circle minus triangle? Now in this case, because this wasn't shaded, it's not as simple as circle minus triangle. This would be circle minus triangle. But on the one I asked you to do, only 2 out of the 3 parts are shaded. So that's why I have to multiply by 2/3. We want 2/3 of the circle minus the triangle. So that should always be your first line, is what shapes are you combining, how are you combining them. Second one, I want you to change those shapes into whatever formula you're using. So if you're using pi r squared for the circle, there it is. For this equilateral triangle, I decided I'm going to use the 1/2 AP formula. So there it is. So now I know what values I need to go hunting for. I need to find the radius of the circle, the apothem of the triangle, the perimeter of the triangle. So what do we know so far? Well, that 7 is the radius of the circle. So there's that one. I know that number. Still need to get the apothem and perimeter. So let's draw that. Here's the apothem. So from the previous lessons, since this I said is a regular polygon, we can get the angle measures, in this case 60 each. We know the radius bisects the angle, so that's going to be a 30-degree angle, and this would have to be 60. So, special right triangle, 30, 60, 90. If the hypotenuse is 7, short leg is 3.5, and the long leg is 3.5 root 3. All right, so now I know my apothem. I've got that number. I also need the perimeter of the triangle. So that's the length from here to here for one side, and then times 3. Well, if this is 3.5 root 3, that means this is 3.5 root 3, so I guess it's going to be 7 root 3, which makes the perimeter 7 root 3 times 3, 21 root 3. So now I know my perimeter. I've got all the numbers I need. So now I can plug in and get my answer. 2/3 of pi times 7 squared minus 1/2 times the apothem from my picture times the perimeter, 21 root 3. I'd probably do a little bit of simplifying here first. Let me grab my calculator and type in a couple things. I'll tell you what I typed in. So let's see. I would change 7 pi squared to exactly 49 pi. And then 1/2 times 3.5 times 21, just to simplify all that, comes out to be 22.75, but I also have that factor of root 3. All right, so now I'm going to type this into my calculator because I think I said nearest tenths when I first started. So 2/3 parentheses 49 pi minus 22.75 root 3. So 2/3 of the circle minus the triangle, and the answer is 76.4 centimeters squared. We got a shot of that? All right. So I know that was a lot. But I want you to maybe watch this video a couple of times, and when you try the problems, I want you to remember to first write out what the shapes are. Are you adding two shapes together? Are you subtracting their areas? Then change the words to formulas, and then show me what numbers you're putting in your formula, because that's going to help me find where your mistakes are if you make mistakes, as opposed to having work kind of scattered all over the place. Good luck!